All right, coming back. I don't know what happened, but the video kind of quit, so we're starting the second half. I've got my trusty sidekick here. Help me, Mr. Dwight K. Schrute. He'll be guiding us along our mathematical journey for the rest of the trip. He wants to talk to you guys about some f of x here, and he also wants to talk to you guys about implying some vertex form. So what we got to see here is we got right f of x equals x plus 3 plus 1 in vertex form by completing the square. Well, you guys have completed the square a lot when we did, probably, I think it was chapter 2, chapter 3, perhaps, I can't remember. But if you'll remember, what we had then was x squared plus, so ax squared plus bx plus c equals 0. Here we have actually f of x equals, so it doesn't equal 0 now because we're finding a function, so we have f of x equals x squared plus 3x plus 1. So Dwight, if you would, I would like you to go ahead and grab my workout sheet for example 4. I thought I'd just show you guys step by step here so I could, because I know the book doesn't always, Dwight, it's not that heavy, it's a sheet of paper. Okay, Dwight, just let's sit down. I got this, guys, no problem. So we have f of x equals x plus 3 plus 1. Well, one of the key things I want to point out to you guys, if I could, is bringing out a, b, and c, so ax, bx, c. So I want you to also focus on b over 2 squared, because that's what we're going to be bringing out for our portion of completing the square. So we're taking out our original here, and we're going to set it up, if you would, right here in factored form. So we rewrite it as ax plus 3 over 2. 3 over 2 is our b over 2. b is 3. 3 over 2 squared. So that's 9 and 4, because 3 squared is 9. 2 is 4. You take the opposite when you're bringing it out over here, and you get negative 9 over 4. One thing, just so you don't get confused where the 1 came from, and you can even see this in your book, if you see that little kind of space right there they left open, that's where they just brought the 1 out, so you could put your 9/4 over there. All right, with that being said, we're going to be solving. One thing that you notice that's different from this is you solve for 2x's when you're completing the square of just a plain quadratic, but this one's a function of a quadratic, so you're going to be finding an x and a y. So what we did here is we brought down x, they're both squared if you notice, x, 3 over 2x squared, I brought them down, and x plus 2, 3 over 2 equals 0, if you will, so I'll show you what I'm writing here. X plus 3 over 2 equals 0, bring over. And that gave us x equals negative 3/2, all right? Plus 1 plus negative 4. Now we solved this right here, but you have to have common denominators before you can even add these together. So to give a common denominator 4, I worked it out over here just so you could see. 4 over 4 minus 9 over 4 gives us 5 over 4. And that'll solve for our last portion of our vertex. So our answers we should have are x equals negative 3/2 and y equals negative 5 over 4. And I want to zoom out here, that way if you guys want to take a moment just to kind of look and see what I've done. And if you have any questions, feel free to ask me at any moment, text, call. If I can't get to you at the exact second, I'll holler back at you. And if you need to pause this, you can. All right, let's move on to example 4. Dwight, if you could help me get this out of the way, I'd appreciate it. Okay, just, yeah, there you go. You're doing good. All right, thanks, Dwight. Let's zoom on down here to example 5. We'll zoom in. Now, same concept, basically, if you will. We're going to be completing the square, if you'll notice. All right, so I'm not going to really spend as much time on this just because you guys have already done it. But one thing I do want to point out to you is you're still using your b over 2. But something else I want to real quickly bring, and I worked out a little bit here, and I want to show you things that I want to put to your attention. Make sure that you have brought out your a, your h, and your k, because you want to make sure this is in vertex form. All right, vertex form. What is it, vertex form? Well, it's ax minus h squared plus k. So, with that being said, I'm going to have to zoom in here again. make sure that you do not forget to use your b over 2. If you'll see right here where it says the red, that means you're substituting in b, which was what? Well, b was, so b over 2, this time it's just going to be 1. And one other thing I want you to focus on is your test points, okay? Your test points are going to give you your vertex right here. And your axis of symmetry is going to be coming up on the y-axis. It's the number that splits your vertex. Now, I know this can be confusing, but one thing, like I said, I want to make sure that you guys realize is your test points, again, are numbers that you make up. When you're completing the square, the difference is this time is you're using your numbers that, instead of setting it equal to 0 as we did before, you're using your function, which is f of x, p of x, or whatever they choose. So this time you're solving for an x and y instead of two x's. So remember not to forget to use, and I'll take you back to 4, example 4, your b over 2, and that's for completing the square. All right, and so just make sure you implement that in and solve it just like you would it, the previous equation on example 4. Use the exact same simplification for example 5. All right, we're going to go to our last example here, and I'm going to have Dwight, if he would go please, and get us example 6. All right, so this is going to be the last example we're going to look at here because I'm not going to give you any problems over example 7, so you guys won't have to worry about that. But when you're given f of x equals x squared minus 2x plus 1, and let me flip the page here so we can kind of look at that also. When you have x, let me zoom in, x squared minus 2x plus 1, you're stating the vertex. You're going to point out a couple of different things, all right? You want to make sure that you get a, b, and c from ax squared plus bx plus c. All right? These are your references I want you to be familiarized with. For finding h, it's negative b over 2a. For finding k, c minus b squared over 4a. Those are the things I really want you to focus on, okay, when solving this problem. So you're going to find out if this parabola is a maximum or minimum. Well, how are you going to do so? We're going to take some of our given coordinates that we know. We're going to take, or we know a is -1, b is -2, and c is 1. So we were able to identify that portion of it. Now we want to take and identify h. Well, let's start solving in some stuff for h. H is going to have what? Well, h is going to be, for b, solve -2 on top times 2 times -1, because all I did was substitute in my given numbers here into here. And then for c, there's one thing that they kind of, it might look a little trickier for you. It says that you're solving for a vertex with on the axis of symmetry, but it says without completing the square for f of x. So your last two that we did, we were completing the square. This one says do without. All right, so we want to make sure that we're focusing on the last portion too when it says solve for k. This one's saying that you're going to take f of -1 equals, and these are just numbers I'm getting from plugging in right here and using our equation. So if we had c was -1 because it's going to be on the opposite side. We have, x was -1 also, so you're going to put in here, it was squared, minus your 2, minus your 1, plus 1, plus plus 1 equals 2. So again, all this is basically just taking your reference points, you're taking your givens, solving them back in to your equation. Now what you're trying to do is try to find out your vertex, all right? And by doing so, we were able to conjure up and realize that, and this is just by everything we did above here, we're able to see that our vertex is -1, 2. If it's -1, 2, that means our axis of symmetry is going to go up at, that means it's going to come through a portion on our y-axis, so it is going to be -1. So vertex, and this is axis of symmetry. And again, guys, I apologize for my poor writing, but I figured this is going to be a little easier kind of look at the book instead of trying to draw everything out, because my drawings are terrible, as you can see here. And I want to thank Dwight for helping us here, and he said if you have any questions, please feel free to call us and or text us, and we will get back with you guys. I'm going to be posting your all's homework on your page, and I hope that you guys are having a good time off. And again, can't wait to see you guys. Miss you guys. Any questions? Holler at your boy, and I'll talk to you later.